Hi, this is Mrs. Clark, and welcome to my video on notes on inverse functions. So, let's see. We just did our lesson about learning about the very introduction to inverses. So we're going to take some introductory notes here and do a little bit of example work so we can remember what we talked about in the lesson, and there'll be more to come, but this is just the beginning. So under the basics, let's talk about what we said inverses were. We said inverses undo each other. I'm going to start by writing that up here. Inverses undo each other. That's the first thing that we need to remember. The second thing is I showed you a notation using function notation, how we note that we have an inverse function. So we're going to write that down. Notation. And I'm going to do f, because that's the one we use most often. This little -1 in the exponent area, and then x in parentheses. And so what this means is the inverse of f of x. All right. When we talked about inverses undoing each other, we talked about how the inputs and outputs are reversed. So I'm going to write that down too. And we looked at the two lines together on a graph, and we noticed that they were a reflection of each other. So I'm going to make a note of that too. Inverses are a reflection over the y equals x line. So those are our 4 basic things that we came up with from that first lesson. I'm going to leave the notes to my future self blank. You can always add things in there as we go. If I'm saying things that you want to write down that I'm not writing down, if you want to write something in a different way, put a different example. But I'm going to go through pretty much the example that we did in the notes or in the video together, so we can have that in here to look at when we're coming back to it. And then we'll draw the graph as well so that we have that to look at. So that's what we're going to put under our example. So we had our first one started at 0.5, then it went 1, 5.75. This was Carlos, if you want to title it. Then 2, 6.5 or 650. 3, 725. 4, 8. If we extend it one more, it's 5 and 8.75. So we looked at from here, whole number to whole number. We saw how it was increasing by 3 on this side, and whole number to whole number on this side, it was increasing by 4. And then that meant that our rate of change, or our slope, was $3 for every 4 pounds. And when we divided that out, we got the unit rate, which was $0.75 or 75 cents per pound. So I think keeping it in the fraction form is important to show how it relates to this one, but also the unit rate is helpful to see how we got the change from 5 to 5.75, and then plus another 0.75 to get 650, and so on. For Carlita's, we remember that the inputs and out, I'm not spelling right, Carlita. The inputs and outputs were switched. So we flip-flopped both of the numbers, 5, 0, 5.75 and 1, 650 and 2, 725 and 3, 8 and 4, 8.75, and 5. To go that one more. And then we can show the same thing from 0 to 4 was adding 4 on this side. And when we go from 5 to 8, we're also adding 3. So hopefully we can see that the numbers are swapping. When we write our slope for this one, it was 4 pounds over $3. So when we do our unit rate for this, we didn't do this when we were looking at it, but when we divide them, it's going to be approximately 1.33 pounds per dollar. So when the X and Y are swapped, the words also switch. So this was dollars per pound, this one's pounds per dollar. And so I like having it in the fraction so we see that it's reciprocal, but if we look at the numbers, we can see that they're totally different rates. All right, then we wrote our equation. So for this one, we had, I'm going to use D of P up here, even though we were using C of P on the other one, just because that's what's on the table here. D of P was equal to our slope, which was 3/4, times P plus 5. And for our Carlita, it was P of D equals 4/3 times D minus 5, all in parentheses. And then, if you remember correctly, we multiplied through. I'm going to not write that down here just for now, just so we can see the inverse plus 5 and minus 5. The order of operations are different. That's why there's parentheses in this one. You're welcome to go ahead and multiply that through if you'd like to, but I'm really more interested in writing down the fact that this one is the inverse of D of P, 4/3 parentheses D minus 5. So this notation is really important because these are inverses. I'm going to label that. Okay. Now, when we look at the graph, we graphed Carlos. It was over here at 5.05 and then 4.8. Grab my ruler, make a quick line. We have Carlita. She was down here at 5.0 and 8.4. Make a quick line for that one. I know I'm going much faster this time, but I know that we just did this, so it should probably still be fresh in your memory. And we might want to do two things here. Show the rate of change and show that this is up 3 over 4. And we can show that this one is up 4 over 3. So we can see how they're reciprocals. You might even want to write that word here, actually. Reciprocal. With an S. So we have that word to use in here. And then we might want to add to our graph that y equals x line so we can remember that they are reflections of each other. So that would be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, all the points where x and y are the same, all the way up to 8, 8. So I'm going to use this to connect to here, draw a little dashed line. This is y equals x. And we may want to say mirror images. This one and this one. All right. So that kind of brings together everything that we talked about and learned through our lesson. This is where we're going to start. We'll obviously develop this more and go more through what inverses are and all the things that we're going to do with them, but just this is the beginning. So make sure, let's get this glued into our notebook on page 32. And go ahead and cut it out, glue it in, and look to the agenda for what to do next. Thanks for watching.